the reduced voltage starter and how it achieves that, and look at what we're going to do for our practical. So you've got a couple of tasks here. You've just got to drop the control circuit and the power circuit for this starter, just like you've been doing for the last couple of weeks. So let's have a look at it. We'll look at these three files here. These are the ones we're going to play with. So I'll just open up the power circuit first. Okay, so let's look at this circuit here, and this is the power circuit. I'll just delete some of this stuff. Sorry, just bear with me. Should sort my shit out. So let's follow one of the lines through. Okay, so what happens is this contact here. Here's our main contactor, and here's our C2. So we only use two contactors for this control circuit, so it's quite simple. So I'm just going to go down one line. There's line 1, go through the circuit breakers, through the isolator, through our main contactor. So we push our start button, our main contactor comes in, comes through here. Our C2 contactor is open, so it can't go through there. It goes through a resistor down to the motor, and then returns. Okay, let's say these are star connected. It doesn't really matter, but we'll start connecting for an example. Okay, so when we first turn on our controller, our main contactor comes in. The power delivered to the motor is delivered with a resistor in series with it. So if we, for example, I'll put some numbers in here, had a winding here of say 10 ohms, and that these resistors here were all 10 ohm each, just to make the maths nice and easy, we would get our 230 volts across these 10 ohms. So it would actually halve it. We would get 115 volts across these resistors because they're in series. Our current goes through them, and what we're doing is we're building a voltage divider, and we would get 115 volts across this resistor here. So that's the idea behind this reduced voltage starter. What we do is we put a resistor in series with the winding. So when it starts up, they've got twice as much resistance there, twice as much resistance, half as much current, okay? And so we start it, twice the resistance, half the current, so it'll start going with a reduced voltage. And then after a specific time, remember our timer? Our timer will kick in and it will close this. So let's have a look what happens when this closes. I'm going to delete all this stuff away. And I'm going to close this. 2, 3. Let's look at that same pathway. It goes through here, up here, down here. Doesn't go through the resistor now. Goes straight down to my 10 ohm winding. So now I have 230 volts across my winding. Okay, so how does it work? You start up, main contactor comes in after a predetermined time, maybe 3 or 4 seconds. The second contactor comes in. Before the second contactor comes in, we have a voltage divider with these resistors in series. Okay, so these resistors are only used just for the starting of the motor. So they might only be used for a few seconds. These resistors take a lot of current through them. So they've got to be big resistors, and it produces a lot of heat off them, okay? So they're like little heaters. A lot of heat comes off these. So they're going to be big resistors, huge resistors, okay? And they're just going to be used just for that initial start as a voltage divider. We can fix the value of these to suit. It doesn't have to be half like we had there. It doesn't have to be 10 and 10. We could set this up maybe at 20, 5, 6, 4. We just set these values to suit our application. Once the motor's up and started, we then bring this contactor in, okay? Then our full voltage is across the motor, and these are no longer used. That's how our reduced voltage starter using resistors work, okay? So sometimes it's known as a primary resistance starter, reduced voltage starter, but what's important is it actually reduces the voltage across the winding. So that's the control circuit. let's have a look at the sorry, that's the power circuit. Let's have a look at the control circuit. I'll just stop this.